Alright, hello again everyone. In this video, I want to finish what we started in Factor Label Part 1 and work on Factor Label Part 2, which is going to be conversions between our metric prefixes. I would have your packet handy, because we're going to reference those prefixes that are on page 30, and page 31. We'll work some problems there. And you might also want a calculator, and you might also want some scrap paper to put some of this down on. So let's take a look at Factor Label Method Part 2 using our metric system. So remember, a couple classes ago we had our little introduction to the metric system video, where we learned that, again, our metric system is made up of prefixes and base units, where we can use prefixes to adjust the scale of that base unit. So like if we're talking something really large, like how much information we can store on a hard drive, we might talk terabytes, so a whole bunch of information. Or if we're talking something really small, like the size of an atom, we might do something like picometers or nanometers, where that prefix pico and nano with their negative exponent are, again, 1 billionth for nano or 1 trillionth for pico of something. So you definitely want to make sure you know these and have this chart handy. So our steps are very similar to normal conversion factors, to kind of what we talked about, I should say normal factor label method, to what we worked on last time. What's going to be different is how we fill in our conversion factors. Once we set up our units, our larger unit is going to get a 1. What I mean by larger is I'm talking about our units with a more positive exponent. So the larger, the more positive exponent prefix is going to get a 1 next to it. And our smaller unit, that's going to be our prefix that's smaller, that's more negative, is going to get 10 raised to the x. And we'll talk about what that x is here in a second. Because basically what we're going to do in our conversion factor is set up that ratio, so it's one of our larger units is going to equal 10 raised to the correct number of our smaller units. So let's try this. So for number 8 on page 31, we have 8 decigrams to grams. I'm pretty sure that's deci. I'll double check. Yep, deca is DA. For some reason that always confuses me. So I recognize this as a metric conversion because I'm only changing the prefix. That's kind of what makes it metric to metric. Notice I have deca there, which is 10 to the negative first. And then I have just G. Remember that as our base unit. It's grams by itself, which would just be 10 to the 0. So metric to metric, we're changing the prefix. So I set it up, write my given over 1, set up my conversion. Unit to cancel goes on the bottom, unit I want goes on top, and I can do that. As long as it's metric to metric, I can always do that in one step. Because as you'll see, it's only one step, again, to change between our prefixes, always. Any two prefixes or the base unit, it's always one step. So now I need to figure out which one of these is larger, my deci or my base. So I kind of did this work up front, but our base unit is the larger one. It has the more positive exponent. So again, I'm going to write a note up here that when I say my larger unit, I mean my larger prefix. We're talking larger prefix. It has the more positive exponent. And I'm just going to abbreviate exponent EXP. So because, again, my base unit 0 is greater than negative 1, it's more positive, I'm just going to write a 1 there. And then next to deci, it's 10 to the x. So remember our smaller prefix the one that represents a smaller amount, is going to get 10 raised to a specific power. So I'm going to start by writing the 10 there. And we find that x by looking at the absolute difference, I should say the difference between our two exponents. So in this case, difference between 1 and 0, I should say negative 1 and 0, is just 1. So that would just be 10 to the first. Again, where I get my x from with my smaller prefix, or smaller unit, is by comparing the value of my exponents. Deci's 10 to the negative first. Our base unit is 10 to the 0. Difference between 0 minus negative 1 is 1. Okay. So multiply across the top, divide by the bottom, 5 divided by 10, 0.5. 1 sig fig going back to our given, and new unit of grams. Okay, let's try another one. 700 millimeters to nanometers. Again, it's going to be a one step because all we're doing is changing milli to nano. So unit to cancel on the bottom, unit we want on top. Okay, so again, that's milli here, which is 10 to the negative third. And N we know is nano, which is 10 to the negative ninth. So we compare those, and which one's larger? Which one's more positive? Milli is more positive. So milli is going to get a 1. Because again, what we're going to set up in our conversion factors, we're going to figure out how many nanometers are equal to 1 millimeter. So again, we know next to nano is going to be 10 to the x. And remember, we get x by comparing our exponents. So we got to find the absolute value, the positive difference. Remember, x, that x right there, should always be a positive number. Always, always, always. Always positive, never negative. So the difference between negative 3 and minus 9. So I'm actually going to put that into my calculator just to show you I mean the truth here. So I do negative 3 minus negative 9, and I get that answer of 6. So my exponent would be 6 here. Millimeters cancels, good. Unit we want is left. So now I would do the math, 700 times 10 to the 6. A couple ways we could write this, 700, and then let's add 6 zeros. And then our new unit of nanometers. And that would be our final answer. I'm going to do number 10 as well. You could always pause the video, set it up, and see how you do, but again, I'm going to work through it real quick here. So write my given, put it over 1, set up my conversion factor. I recognize this as a metric conversion because all I'm doing is changing my prefix. So seconds by itself, that's our base unit, 10 to the 0. Capital M, that's mega, that is 10 to the 6th. So mega would get the 1 because it's a larger unit. Our base unit, it's 10 raised to an exponent. Remember the x there. And remember, we figure out the x by comparing the two numbers, by finding the difference between them. In this case, it's a little bit easy. It would just be 10 to the 6th. So seconds cancel. So 32 divided by 10 to the 6th. So I think we should have 0.00032 megaseconds as our final answer. So that's the trick for your prefix conversions. All one step, and you have to know what your prefixes mean. Good luck.